So in problem 6.4, we're going to be asked here to predict the sign of delta G, and we're going to be given information about the enthalpy change, and the entropy change of the system that we're asked to predict whether or not delta G will be positive or negative. So we're going to use our Gibbs free energy equation here. Delta G is equal to the enthalpy change minus the temperature times the change in entropy. So we have an enthalpy term and an entropy term. So in example A, we see that we have an endothermic reaction. So that tells us that we have a positive value for delta H. And then we have an increase in entropy. So that tells us that we also have a positive value for delta S. So depending on the magnitude, the size of these values, we won't know for sure whether or not we have a positive or negative delta G with only this information. So this example would be temperature dependent. And we're asked also, if something is temperature dependent, to describe how delta G will be affected if we increase the temperature. So if we raise the temperature of this temperature dependent process. So if we raise the temperature, some positive value would have some positive value subtracted from it. So at a high enough temperature, this reaction would be considered spontaneous, we could say, because we would have a negative delta G. So with example B here, right, we can plug into our delta G equation as well. And for B, we're given, let's change the color here to something else. So we're told that we're exothermic, so that's a negative delta H. And then we have an increase in entropy again. So that would be minus some positive value. So both of these terms contribute to a negative delta G. So this we would say is spontaneous at all temperatures, this process. All right, so let's take a look at C. So let's change our color again. And in example C, we see an endothermic reaction. So it's positive, and then a decrease in entropy. So minus some negative value. Both of these terms would contribute to a positive delta G. So we would say then that this process would be non-spontaneous at all temperatures. Right? We don't have a temperature dependent equation option for example C. Let's look at D now. So we're told we have an exothermic reaction and a decrease in entropy. So now we have, again, competition between our terms. So our delta G would be exothermic, negative, minus some negative value. So we have, depending on the temperature, how will this delta S factor, right, change? So at high enough temperature, right? So if we increased our temperature here, this would become more positive, right? The second term, right? If we increase delta T. So we could say then this reaction would be spontaneous at low temperature, so at a low enough temperature. So if we decrease temperature enough, this value would become insignificant and we would see a negative delta G. All right, so that's everything for question 6.4. Next time we will continue with 6.5.